All right, hello everyone. My name is Jeffrey Cannell. I'm also known as Emozilla out there on the wide internet and the Twitters of the world. I'm the co-founder of NOUS Research, and this is a little talk about how we are trying to make an open source GPT-4. All right, so a little bit, you might know about NOUS Research, might not. What do we do? I like to tell people we're basically just kind of like the homies on the AI Discord. We started out as a bunch of people talking about how we can make open source AI models not suck. And this is back when they sucked considerably more than they do today. And we would just get together and be like, hey, I noticed you're working on this, I'm working on this. And out of that came a group of models known as the Hermes models. And the Hermes models are probably, I'd say, the most used open source AI models that are out there right now. Have like tens of millions of downloads, and we hear that they're used in all sorts of cool things. And the thing about the Hermes models that make them like different from what you're going to get from like a llama model or something like that is that it doesn't really like patronize you, right? It does exactly what you want. And this is sort of when people talk about alignment in AI, it's kind of an interesting thing because often, and we've seen this now with like the release of Gemini, that sometimes the model is trying to align you and not the other way around. So what we do at NOUS is we make open source models that everyone can use and open source AI tech, and we do it in a way that we think is pretty fun and unique. So what is the actual problem that we're setting out here to solve? It is, what is the best open source model? If I asked you that and you were someone who wanted to like go download some open source models and use it, and I said, hey, well, which one are you going to use? You'd probably think to yourself like, well, what's the best open source model? And you would have a difficult time answering that question. And in fact, the best way you'd probably answer it would be to like go on Twitter and be like best model and see like what people are like talking about. But that's not very quantitative. And the reason for this is because well, oh yeah, I forgot. It depends on what the meaning of the word is for all the people who grew up in the 90s. And so let's talk about the good old days of AI, the good old days of AI research. Back in the day, you know, the only people working on AI models were sort of at like academic research institutions, or they were at companies. And what people did is they were really nice and they made these like benchmarks that you know, you could compare against. And what would happen is you would train your little model and you spend all your time working, and then you'd maybe publish a paper, and then you would submit your model to this organization that maybe would then go and benchmark it, and they would come up with some results, and they'd post it, and it would be super official, and everyone in every paper would quote the same model score, the same benchmark scores, and all of them will have been evaluated the same way, and what was really nice about it was everyone sort of agreed not to cheat. And this was a very important piece of the whole puzzle, was everyone agreeing not to cheat. And this came out of the fact that, like I said, most of these were put out by you know, quote unquote professional organizations, and they would have you know, if they cheated, they would get the proverbial academic finger wag at them, and so they didn't. And so we would end up with nice things like this, which was the super glue benchmark, which is where you could go and say, oh, I see, this is the best model for this size. And it was very easy, and everyone was happy, and all things came along. And then something happened about a year ago, and that was the proliferation of all the open source models, which was good. But what this did was it created a bit of a perverse incentive. So no longer were there these big gatekeeping organizations that you had to submit your model to, which is good. We're all fully in favor of open source and creating disintermediated and permissionless systems, which perhaps we'll come back to later. But what this led to was the proliferation of what is known as the Hugging Face Open LLM Leaderboard. And the Hugging Face Open LLM Leaderboard is where you can go and submit your model, and it gets evaluated on a series of benchmarks, which are basically, you know, tests that you can run the model against. And you'll remember my previous assertion that a lot of the old benchmarks relied on this thing where everyone agreed not to cheat. And we sort of no longer have that arrangement. And we are praying that it is not changed any further. And the reason for that is because as it stands right now, getting to the top of the Hugging Face LLM leaderboard is like, you know, an accomplishment. And it is an accomplishment, right? Because it is difficult to do. But when your sort of only incentive to do this is to like, you know, see your name at the top, you may be inclined to take some less than savory measures to get your name to the top. So all of these, tasks here are CalSwag, MMLU, Truthful QA, and so on. The test set for them, the questions that are being asked for in this leaderboard are open. You can download them and see them. So suppose you were someone who wanted to like get some notoriety and wanted to get your name to the top of the LLM benchmark, and you knew exactly every question that was going to be asked of your model in the test. What might you do in this situation? You may be inclined to go ahead and start training on all of the test questions. And this is like, okay, like first of all, it's you know, it shows that transformers can, you know, learn and that the models work, and your score will go up. But if we go back to like this over here and then say, what is the best open source model? Do you think that the model trained totally on test questions and only on test questions, gets the highest score, is likely to be the best open source model for you? And the answer is probably not. So now we have this problem where like you as the user, person trying to create agents who are trying to fine tune a model to do some downstream task, don't really have like the information that you need to know what the best model is. And all of this, if you think about it, is really just a downstream effect of the incentive structure, right? Everything in life sort of takes its path of least resistance, right? And if the only incentive that you have is getting to the top and seeing your name at top, then that is the behavior that you are, whether, you know, it wasn't on purpose. Hugging Face didn't mean for that to be the case. And like what they were doing, what they do is like fundamentally good, and it's not bad in any way. But when that's sort of the incentive, everything just sort of flows naturally in that direction. And that's where we stand today, where it's very difficult to know what the best open source models are. And so at NOUS Research, what we believe in is like disintermediated access to local open source AI. And so because we believe in this, we actually have to like be able to tell people, how should you know which models to use? And furthermore, not only just answering that question, there's the larger question of, can we develop some mechanism so that the behavior that we want, which is the creation of the best open source AI models, can we make it so that that's the actual path of least resistance? Because that's the thing that will actually create the result we want, right? Then people always say, show me your incentive, I'll show you your result. Well, that's sort of where we stand now. You've probably seen this before. It's a little bit of like a trope, right? It's Goodhart's law. It was actually formed originally by this much more technical thing where he says any observed statistical regularity will tend to collapse once pressure is placed upon it for control purposes. But what this means in a little more plain English is that when a measure becomes a target, it ceases to be a good measure. And that's where we stand today with a lot of like the open source benchmarks. And so out of that, we sort of asked ourselves, is there a way to do this better? So what do we want? What are we actually trying to get? We thought a good goal, like a noble goal to start out, would be an open source GPT-4. It's not perfect. When I say this to people I say like, why stop at GPT-4? And this is a fair question to ask, but my reply to that is always, let's get an open source GPT-4 that everyone can use, and we'll go from there. We'll go from there after, right? Like we're trying to create some achievable goals that will meaningfully make open source AI better for everyone on the planet. And so for it to work, we need it to be permissionless and decentralized. We are not sort of in the business of creating a model behind closed doors that's the best and then dumping it on the world. There are organizations that do that, and the few that have the resources to do that right now from the pre-training perspective are doing the Lord's work. But that's sort of not kind of where we grew out of. We grew out of Discord, we grew out of Twitter. A lot of us have crypto backgrounds, and that wasn't sort of our ethos that we did. So we said, is there a way to do this in a permissionless and decentralized way? And really the strategy, like I echoed a second ago, was that the strategy is make people want to do the thing we want to do. I know that sounds like groundbreaking, right? But like, if you could solve that problem, you've solved pretty much every problem. So the question is, how do we make people want to create high quality open source models that actually are good at downstream tasks? So we used, you may have heard of it, you may have not, we used a blockchain called BitTensor. So BitTensor is a substrate chain that essentially is modeled after a deep neural net. So it creates these concepts of nodes that interact with each other in a similar way that a densely connected neural net works. In the fact that each of the nodes, which themselves are public-private key pairs, have this relationship amongst each other where they have these weights, and these weights represent like some trust or some other value between them. But what's interesting is that like if you think about a deep neural net, like basically every node is connected to every other node and has their own view of what they think is the correct value for these weights. And then the network as a whole sort of comes into consensus and says, well, everyone thinks this, that, this. This is sort of the, it's not really the average, but it's the way that the network as disparate pieces are coming together to consensus on what how all these nodes should be interconnected. The thing about the way BitTensor works is that it's really kind of just like a springboard platform for these things called subnets. And subnets are basically the actual application layer built on top of BitTensor. And in that subnet, in that application layer, you as sort of the subnet designer are able to create whatever incentive mechanism that you want to. So it's kind of like, in the same way that you've probably seen other, Avalanche, for example, has like subnets too, right? Where you can basically create your own rules for the way like the EVM works on. In a similar way with BitTensor, you're able to design your sort of own incentive ecosystem on top of this design space of having these interconnected nodes that each all have these weights together. So we created a BitTensor subnet and with the goal of creating an open source GPT-4. And so that is what we call subnet 6. Very, creatively named because it's the 6th subnet. Actually, what's interesting about the subnets is they exist in like competitive space. So there's only 32 at a time, and like whichever one people are using, the top 32 that are like used the most, basically, are there. And then if someone else comes along, then you can like outbid someone to be one of the 32. So how does subnet 6 work? The way subnet 6 works is that models are submitted to subnet 6 by miners. Now, we can use the phrase miner here. It's funny that like all things that are old come new again. You know, we had the days, 7, 8 years ago where only, ETH people were buying every GPU on the planet to like mine ETH. And now every AI person are buying GPUs to like fine-tune models to then get crypto again. So it's fun that we brought it full circle. But the models are fine-tuned and created by any mechanism that the submitters choose. This is a key piece because it actually becomes like a technical competition. So the models are submitted to subnet 6 by the miners, and what we do is we take data from a different subtensor subnet, which is subnet 18, and what subnet 18 is doing is it is constantly calling the GPT-4 API with novel questions and instructions to generate brand new synthetic data all the time. And this essentially is like the key piece that's the differentiator, which is that rather than having this fixed test that anyone can cheat on, we use the incentive mechanism of BitTensor to fund the creation of new synthetic data all the time, 24/7, 365. I guess, just lining Sam Altman's pockets, I guess. But, we're constantly calling it all the time and generating new synthetic data. And that new synthetic data has never been created before, right? Like it's brand new. And because it's never been created before, we can use it to evaluate the models that are submitted onto subnet 6. The data is completely fresh, completely new. You can't train on it and you can't cheat on it. And so what we've essentially, the thesis is that if we can make an AI model that in every aspect mimics the way GPT-4 responds to questions. And these questions all have to be novel. They have to cover like the entire space of all knowledge, which obviously we aren't doing it perfectly, but there's been a lot of research into how to do these eval instruct methods so that you're always generating like new questions, and you do like these like almost like a Socratic dialogue with the questions themselves to generate new questions. And so out of that, we're able to create this brand new data that has never been seen before that we can use to evaluate the models that are submitted to our subnet. And then validators on the subnet test the new data and get the loss, which is basically like a measure of how close the model was to predicting what the actual text was. So basically, pull back curtain a little bit, LLMs work by not actually predicting the next token, but predicting the probability of all words together. And they assign to every word in the vocabulary a probability. And then you use something called a sampling method to like pick which words to use. But because of this, you can actually create this measure of like how close was the model towards the output of what GPT-4 said it was going to do. And so what we do is we then take this brand new synthetic eval data and we test and we create basically like a winner and loser. It's a competition to see who can get the lowest loss, because you want to be as close to GPT-4 as possible, who can get the lowest loss on the brand new synthetic data. And then what we do is we take the emission mechanism that's inside BitTensor and we redirect it directly to whoever submitted that model. So now what have we actually done? We're saying if you are able to submit an open source model that's better and closer to GPT-4 on this constant synthetic data, then like you're incentivized, you're earning tau all the time for doing it. And what it means now is that we've correctly incentivized the behavior that we wanted, which is not benchmark chasing, but which is actually creating better open source models. So this is, I guess this, the screen didn't show so far, but this is like a log print of like constantly generated new synthetic data. So all the time we're constantly being, and I guess you can't, yeah, it's hard to read. If you have a nice screen, it's easier to read. But yeah, I can see here, deliberate on the ethical considerations of medical experimentation on animals in the advancement of human medicine, and discuss the effectiveness of psychedelic therapy in treating mental health disorders. So like, it's just this constant like stream of all these different questions. And it's got like, this is the whole like tree of like concepts, and you have ways to like ask it to refine the question. And then finally we take all of that and we ask it to GPT-4. And so this data, the answer that just like came hot off the presses from GPT-4 is what is we're constantly reevaluating all the model submissions on to then determine which one was the best one. So this is what the leaderboard looks like. It is hosted on Hugging Face as well. It's a Hugging Face space. And so this is the Subnet 6 leaderboard. You can see it. I have a QR code for it later in the slide too, if you guys, to get to it. So this is an example. You can see here some guy named DeepNet is winning the competition as of when I was on my flight over here, because I totally didn't make these slides on the flight over here. And you can see that he's winning, and he's just a public-private key, all right? I don't know who this guy is, but he's making better open source models, and so we're gonna incentivize him to do that, right? And so this is the leaderboard here for our Mistral 7B competition. And what's nice about the leaderboard is it also shows you for these competitions, it doesn't just say this guy won. We'll say here's an actual like example of the output that it generates. So we generate a bunch of example outputs as well. You can see how it works. And these models really are becoming really, really good because we've incentivized people to get their, to create models that are as close to the GPT-4 outputs as we can. And what's been really cool to see is that, people in the AI space, which, to be frank with you, sometimes have like a bit of an antagonistic attitude towards people in the crypto space, have really seen that this is something advancing the state of AI by using permissionless, decentralized protocols to like move it forward. And that's something that like resonates. I mean, most people will, give you the sort of like the smell test, I like to call it, does this smell funny? And to many people in the AI space, this does not smell funny at all. And that's awesome because it shows that crypto's fundamental value proposition, which is, disintermediated permissionless interaction between agents, is something that will resonate, And so we've been really excited about the uptake that it's had. It doesn't hurt that we're giving away a bunch of money too. That always helps. But within the broader space of is this advancing the state of AI? We feel that it is, and we feel that we're, by using these primitives, we're able to help show that they can, have meaningful results. To give a little bit of a one-liner, subnet is an experiment in using crypto primitives where it makes sense to incentivize the creation of high-quality open source AI models. We have 2 active competitions going on right now. One, which is the one we launched with, which is fine-tuning Mistral 7B, which is a 7 billion parameter model, probably the best 7 billion parameter-based model put out by a company called Mistral AI, based in France. And then actually just today, we launched our second competition, which is to fine-tune the Gemma series of models, which was released by Google a couple days ago. This is actually a 2B parameter model, which at 2 billion parameters is more focused on edge inference. So you can run a 2B parameter model on your phone. And totally, you're not connected to the internet. You're not you could go turn on, airplane mode, and that AI would the AI model would still work. And so we're also redirecting a lot of our incentives. Right now, we actually have it as a 2-to-1 weight for the new Gemma one to help get that competition going. Because we really think having a GPT-4 that you could, it's not going to be as good as GPT-4, but it can approximate GPT-4 in 2 billion parameters on your phone, completely owned by you, not touching any SaaS API, anything like that, is something worth, striving for and building in the open source community. So that's what we have. In last month, we gave out over $2 million directly to open source AI model creators. And that is not a typo. That is $2 million a month that we're using for. So we're really we're aiming the cannon of how can we advance this. Thanks, I appreciate it. So this guy right here, he's big. What? It is from the native emissions of Tau. So the BitTensor Tau subnet, basically, we as a subnet get 7% of the Tau emissions globally. And then we basically take all of that and redirect it towards the people who can create the best open source AI models. And to go back again, these people on the left over here, these are all open source models that you can download directly on Hugging Face. But the people who made these, I have no idea who they are. They're public-private key pairs submitting on a permissionless network that I don't control, that don't care who it is. What I do care about is that you created a better open source model that everyone can use. Yes? So yeah, so these are all on Hugging Face, and the weights have to be able to be downloaded directly. So that's kind of the key piece is what happens is they actually submit, they sign a message on chain with a link to the Hugging Face model download. And then the validators themselves have no credentials. So they actually have to be able to go download and get the model, there's no trusted, the validators themselves have no trusted access to the models. So they have to be posted publicly so that anyone can download them and be available. And so, because that's the way that we just do, the validators just do an anonymous Git, poll to get what's on there. So it has to be publicly accessible and open to everyone. So all of these, all of the models that are being created and submitted within it necessarily have to be open access and be able to be downloaded. So this is, if you run it real quick, this is a link to the leaderboard that I just showed you. So if you want to get started in maybe making your own model and doing this and learning about fine tuning, no longer do you have to kind of do it for fun, but now there's there's a profit motive behind it as well. But we find that in a lot of things in life that will direct things towards the outcome that we want. So that is a link to the leaderboard that I just showed you. And so just to close a little bit, at NOUS, we're really all about open source AI access, being able to disintermediate the access of this powerful new technology to everyone on the planet. So this has been a very exciting experiment. Like I said, a lot of us came from crypto backgrounds, and seeing how we can use these crypto primitives of permissionless, decentralized interaction between trustless agents it's been awesome to see, and I look forward to how in the coming months, we're going to be able to take this even a step further. So this is really just the start of what we want to build, and we're excited to see and to show off eventually where that comes. So you can follow me on Twitter if anyone's interested. I'm at the Emozilla, not just Emozilla, but the Emozilla is me. or you can follow us at NOUS Research. Or if you want the best way, we grew out of the Discord, I like to say. We came out of it. That QR code is an invite to our Discord. So you can join in. And what was originally like, a couple dozen people just talking about it 9 months ago, we now have like thousands of people working, and we have tons of different work groups of like people sharing their ideas of what they're working on to create the best open AI access models. So you can join the Discord, and we're also all on there too. So yeah, that's Subnet 6 and what some things we've been working on at NOUS. Thanks. I think probably have like 5, yeah, it looks like we have like 5 minutes for questions or if anyone wants to talk. Yes. How do we keep synthetic model generation? Oh yeah. So so that is it is an interesting question. So one of the co-founders of NOUS, his name's Technium, is like kind of like the world's like, I wouldn't say expert at it, but he's one of the best people in the world for it. Really the fundamental thing is the eval methods. So it's not just here are the questions we're going to ask, but you actually ask GPT-4, give me some questions about this topic, and then you say, okay, for each of these questions, what are like some arguments for it, against it? What are like some interesting details, connections? So you actually you don't just start with like the synthetic data, but rather the questions themselves are synthetically created by GPT-4, and then you take those questions and then generate the answers to them again and use that as the eval data. So it's not perfect, and we are constantly like evolving the synthetic pipeline to make it better. But so it is really like we're approaching it on the synthetic side. But what we know in AI is that like the data really is everything. The data really is everything. And so it will be as good as we can make that synthetic pipeline. But the Hermes models that people use is almost 100% synthetic data. And that's been proven to be like wildly popular. And this is interesting because there was a question not long ago whether synthetic data, like whether it was like kind of reductionist, whether like synthetic data would like, can you actually make a model better by training on like a model outputs? But we've definitely seen it to be true. Yes. Yeah, so that was done sort of by purpose, I guess. We really want to make like 1 or 2 best ones and make it competitive. So we actually take what we do is we take each of the models, we compare a win rate against each other, and then we do like a softmax on it. And then from that, it like pushes the distribution close to create like a top 4, 5, 1. We split it up with the new competition. Basically now there's like, I guess you could say like there'll be like 10 or 11 winners that are like gonna be getting like a substantial chunk. And we're gonna keep iterating new modalities and new competitions. Because really we have the ability to focus these incentives into making open source AI better. And so we kind of want to like aim that, for lack of a better word, like aim that cannon at all different sort of aspects of the pipeline. We're also looking into doing like, can we make like a model that's really good at math or like at a specific like, downstream tasks and stuff like that too. So that's where we're going to be evolving it like over the next weeks, is just like constantly pointing it at different modalities and see if we can create SOTA models from that. Yes. Mm-hmm. 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 Yes. Well, I would say actually, this is actually really like for all of the quantitative mechanisms, what we're trying to do here, you will still find that like I always tell people like, a tool is a good tool when like you reach for it when you have a problem, right? And so, as people use the models that are coming out of it and they're finding them useful, that's actually like the actual real like done. But the fundamental thesis is that that GPT-4 is very good, which it is. And so if we're able to approach the GPT-4's outputs as close as possible, we will be creating a model that is useful to them. So that is like the fundamental thesis underneath it. And so it's not perfect. And like I said, we want to, in open source, go beyond just that. but this is a good starting point. On the alignment side, I think the alignment question is like so big, it's almost hard to like really like break apart, because often the question is like alignment to what, right? I mean, all of these models exist in like this infinite, almost like infinitely sized possibility space, and almost all possible text that's ever been written, right, is like in the possible outputs of it. And so for this particular project, because we're using GPT-4 as like the baseline, we're not directly tackling it and trying to do that. I mean, we're really just trying to be like, can we create an open source model that is good at mimicking how GPT-4 works? We were not stopping there. We're by no means limiting ourselves to there at the NOUS, but specifically with this project. And that comes down to the empirical ability to like do the comparison. And that's really the problem with all of it, is like, how do you do an empirical comparison of like vibes, basically, right? So we know that people like GPT-4 for some things. So if we're like, well, we can at least get close to that, then we're getting somewhere. So, yes. Yes, so we have a bunch of like, there is one of like the 80 different like subtracks is like, write me a Python program to do this, and write me a Python, or like solve it using, and it'll come up with these weird ones where it's like, write a Python algorithm to find the longest subsection of 2 characters that doesn't contain the word dog, unless it contains the word dog. Then, like, you know, these like really kind of like weird sort of constructions together. Because really what you want to do is, in the synthetic data, you want to touch all of the latent space that GPT-4 covers, right? Yeah. Yes. Yeah. We don't. I mean, the answer is we don't. And I would not in any way claim that this is creating like the best or greatest models that are out there. It's really more about, can we use the existing mechanisms, this incentive mechanism now, to take what was something that was totally misaligned with what the community wants, which is benchmark chasing, and redirect it towards something that is more useful. And I always say, like, better yesterday than today, better tomorrow than today. And if we can do that every day, then we're driving like the space forward. Yeah, yeah, sure. Yes. Yeah, yeah. Mm-hmm. Yeah, well, this isn't directly a benchmark. It's loss against GPT-4 synthetic data, and that's a different thing, really, because benchmarks before would be like, ask you a question. It's very much the SAT, right? Ask you like a complicated question, A, B, C, or D. What's the right answer? And then if you pick A, like you got it right. Whereas what this is actually doing is, it's like at every word, the loss is calculated over the entire output of the text. So what it de-emphasizes is like absolute correctness for a specific answer, whereas like a benchmark is like, did you get the number right? And this much more highly emphasizes being able to cover like the entire, the expressive space of the way GPT-4 reasons about problems. So you sort of like get chain of thought. You get all of that stuff that's baked into GPT-4 like for free, because your loss is calculated at every token as you're going along. And then it's summing that up together to get the lowest loss. So it's very much like not trying to score highest on the answer. It's not trying to score highest on the test. It's trying to talk exactly like the teacher would talk at every moment. But like, if you can talk exactly like the teacher, then like you would give the right answer to the question. You know what I mean? So it's very much like a different paradigm than you get from like the previous benchmark stuff that was done before. But I think I'm over at 5, so I'll be hanging out around too, and be sure my DMs are open, a stupid thing to say or whatever. So go ahead and shoot me a message, and love talking about what you're doing. So appreciate it. Thanks.